something, we could get a filter that stays pretty close to this, drops pretty fast. There's a whole world. Bell Labs had like a little team of filter experts creating, and now MATLAB will create it for you, the coefficients H that would give you a response, a frequency response. It'll stay up close to 1 as long as possible and drop as fast as possible and bounce around there. Yeah, so next week, if I come back to that topic, I can say a little more about these really good filters. What was I trying to do today? Trying to see how convolution is used. And this is a use you will really make. So now I just have, I think, about 2 more things to say about this example. Let's see, what are they? Well, first, also all the information is in this h of omega. Yeah. This simple example gives us a way to visualize convolution. And I think we need that, right? Because up to now, convolution has been a formula, right? It's been this formula. That's the formula for convolution. And how do I visualize that? Just think of, may I try to visualize that? Here I have, this is the timeline. The different k's. K equals 0, 1, 2, minus 1. And I have x minus 1, x0, x1, x2, x3. So that would be, it's a little bouncy up and down. And the averaging filter, let me go back to the averaging one. The averaging filter would smooth out the bumps because it would take it would like average neighbors, and that's a smoothing process. As we see here, it's a process that kills high frequencies. Now, what is this visualization I want you to think of? I want you to just think of like a moving window. So here's the input. Now I move a window along, and that window. So let's say here's the window. I should have another. So that's the window. When the window is there, it takes the average of those two. That gives me the new output. Now think of the window as moving along here, taking the average of these. Move the window along, take the average of these. Move the window along. Do you see the sort of, this is what a convolution is doing. This is a picture of my formula, sum of hk x L minus k. So the window is the h's, is the width of the h's, and as that window moves along, I mean, you could design a little circuit that would do exactly this, that would do the convolution. You just have to put together some multipliers because you have these h's, these like halves, and you have to put in an adder that'll add the pieces. And so those are the essential little electronic pieces of an actual filter. And then you just move it along, so it needs a delay. That's about the content of a filter, is multipliers that will multiply by the h's. So in come the x, multiply by the h's, do the addition, and do a shift to get on to the next one. You see how a filter works? I think that image of convolution is, it's a little bit vague, maybe this window moving along.